Alright guys, so in this video we're going to go ahead and talk about getting actually into the programming of a microcontroller. So as you're aware, we're not able to go ahead and get around to working with the Vex robotics and actually building the robots, programming them, developing them. But the thing about these Arduinos, okay, and this is why we're going to be using TinkerCAD, these Arduinos are fairly inexpensive microcontrollers. They come in a lot of different shapes and sizes, so we've got some that are designed to fit on a breadboard. Others can be used as parts of fabric and clothing. Some of them are super small, so this one literally plugs into a USB port. Okay. And these Arduinos have been around for a couple of decades now. They are a quick, easy prototyping solution for a lot of electronic needs, and a lot of you may end up using these in your engineering design development courses. So to go ahead and get us started, the goal today is we're going to create a basic circuit, and we've actually got a little bit of a plan prepared. Okay. So plan is we're going to build a basic Arduino controlled LED. We're going to have a switch on it that will start and stop the LED from flashing. Okay. So we'll get back to the pseudocode in a little while, but let's go ahead and start building a circuit. Okay. So as you probably remember from TinkerCAD, when we've covered electronics, we know that we've got a few things that we need. Okay. We're going to need a breadboard. I'm going to rotate that for better orientation. Okay. We'll need an Arduino. Okay. Rotate that as well. Okay. And then we're going to need an LED and a switch. Okay. So grab the LED, rotate that, grab a switch, just use a push button. Okay. So in terms of building a circuit, you guys probably remember a few of the core concepts. Okay. We're going to need power, we need the light. Okay. To go ahead and get that working, okay, we're actually going to use the Arduino as the power supply for the breadboard. So over here in the power functions, okay, we can go ahead and create the wire. Okay, click where you want it to bend. Okay. Can change the color by hitting the numbers. 1 is black, 2 is red, and then we can go ahead and connect it to the LED. Okay, because thinking back into programming, one of the first things that you want to make sure you're doing is you're testing it as you're proceeding along. Okay? You don't want the problems, and there will be problems, you don't want those problems to prevent you from going forward. Okay? You want to make sure you're kind of eliminating them as you continue. Okay? You don't want them just compiling on top of each other, problem after problem after problem, and you can't just narrow down one. So to make sure that our circuit is working, we can use TinkerCAD's ability to tell us what is the different pins. Okay, anode, you may remember, is positive, and cathode is negative. Okay. And we start the simulation, we test it, and we shouldn't be surprised that it blows up, because as you may remember, there's a limit to how much current can actually go through an LED. In this case, we don't have a resistor to limit that, and if you want, you can use Ohm's law, calculate what the resistance needs to be for 5 volts to get down to 20 milliamps. I'm going to go ahead and just cheat a little bit and swap in a 1000 ohm resistor. Okay, and we're swapping that in for the ground. Okay, we're also going to need one of those resistors in terms of the switch. So right now both of those are set up to the ground, to the different components. Okay. And then let's see, the next step is we need to start working with programming. So when we're running the simulation, making sure that our LED is working, okay, you might notice that there is an LED on the Arduino that is already flashing. Okay, and that's going to be similar to what we want to accomplish, but that is a common, program found on newly manufactured parts to make sure that it's in working condition. You certainly don't want to pay $20–30 for a Arduino and not have it working at all. So when we look at the code, we'll actually see some of that. Okay? And by default, TinkerCAD is going to offer us block code. Okay? And I'm fine with you guys using some block code to go ahead and learn this, but I think you're going to get some extra help by actually having the text, okay, show you what is going on in this program. Okay? So by default, pin 13, okay, is controlling the onboard LED, and basically it's doing the same sort of flash construction that we want. Okay? We're actually going to toss that code though and kind of write it for ourselves. Okay? So remember that when we've talked about this, okay, and we can go ahead and take a quick peek at our pseudocode. So our general plan, have the LED turn on, wait, turn off. Okay? And it's going to do that process based on what's happened to the push button switch. So at some point, push button switch is pressed, lights will stop flashing. When we press it again, flashing will resume. Okay. So let's start off with creating the flash construction. Okay. So the basic LED flashing code that we're going to look at, okay, is we're going to have an output, okay, of, we need to switch this out from being always on because of power to being controlled by the Arduino. So we're going to make the positive line go to 11, set it so pin 11 goes high. We can have it wait. Let's see, let's go for 500 milliseconds, okay, and then output, turn it off. Okay. So we run the code, and the LED is always on. This is where you need to go back and think about how the computer is doing explicitly what you tell it to do. So let's look at the text. Okay, in this loop, we turn it on, we wait 500 milliseconds, we turn it off. It instantly then is repeating. Because there's no wait time when we turn it off, it's instantly going back on. Okay, so it's not even staying off for more than maybe a millisecond, so fast that we certainly can't see it. So if we go back into our controls, we put in that 500 millisecond wait, we start the simulation, okay, and helps when you have the code right as well. Okay, so I had it set to the built-in LED. Okay, that's not what we need. We need to go ahead and have that as pin 11. Okay, so what I just said about you need to have that wait command there, we'll see that that's still true. Okay, that's staying always on. We put in the wait command, and we're now getting it into still not paying attention to the code itself. Okay, now that we set it to low, okay, it's flashing because of the way the code is written. Okay, notice that even though that's not connected to that block, okay, because it's underneath, okay, it's still giving us that 500 second delay. We trash that code, okay, that's going back to staying always on. So one of the things that you need to be mindful of when you're using block coding, doesn't necessarily need to be connecting. It is starting from the top of the screen and working its way down. So we can go ahead and put that command back in. Okay, a bit more structured. Okay, one of the concepts that we've talked about, and we've got something working like we want. Okay, so the next step is we need to go ahead and make sure that we get our push button switch working. Okay, we got the flashing stuff figured out. That's taken care of, kind of that section of the pseudocode. Okay, what we need to work on is make sure that the switch will be reading. Okay, so we haven't finished wiring this. So in general, I think we're going to want that to go to positive. Okay, so one side is always positive, one side is always going to be negative, and we'll have the ground kind of share with pin number 5. So, in theory, okay, we're going to throw some comment in. Okay, so So, current thinking, okay, and we will see if this holds true. The push pin is going to be low, okay, the push button is going to be low, and when it becomes high, we're going to change commands. Okay. So, to test this out, okay, we need to start setting up an if structure, okay, and we're actually going to make an if then, okay, because if one thing is happening, we want that to be true, otherwise there's something else we want to be done. And as our test for this, we're going back and using that built-in LED. Okay, so when push button is high, LED will become high. When push pin is low, okay, when it's not high, it will become LED is low. Okay. Now we need to go ahead and set up the structure to make sure that we're checking pin 5. Okay, so pin 5 is going to be one of our inputs. Okay. And we can go ahead and drop that in. Okay. And then in terms of control, okay, we need a hexagon block to go ahead and test that. That's where we go back into our math calculations. Okay. So when, or if rather, okay, we read digital pin 5 and it is low, or sorry, when it's high, okay, the built-in LED will turn on, otherwise will turn off. Okay? So let's test the code. Okay? We're ignoring the flashing light, we're only focusing on the push pin. Okay? So pressing on that, okay, we notice the LED is on, okay? Release the push button, okay, turns off. Okay? So the next little challenge is going ahead and getting this block of code to control this block of code. I think the way to approach this, okay, and this is not going to be the most efficient, this is the foundations of programming. There's a lot of theory that can go into more complex and more better responding commands. Okay? But we're going to go ahead and put a variable into this. Okay? And we're going to have it as flashing. Okay? Basically is going to be an true or false character. Okay? So if this is high, okay, we're going to tell it to set flashing to, actually let's delete that for a second. Okay. So we need to think about what is the variable flashing. Okay. We know a variable of flashing is going to be either high or low, okay, depending on where it's setting it. By default, it's probably going to be low, just because of the way that you usually declare them, and we can see that in the text code. Okay, flashing equals 0. That's a low value. Okay. So we're going to want to set up another if structure. Okay, specifically an if else. Okay, so if the push button is pressed, okay, and if flashing is high, okay, and is basically saying equal to high, then we will have set flashing to low. Okay. Now we copy that block, okay, put it into the else statement, and if it's not high, we want it to set it to high. Okay, so if it's high, set it to low, otherwise, else, set it to high. Okay. From here, okay, we know that we also have a control command. Okay, so similar structure. Okay, if, okay, and we can set up kind of the same thing. Okay, if flashing is high, then we run the flashing constraint. Okay? Otherwise, we don't want it to run. Okay? So let's test it out. Okay? So by default, we know that flashing is low. We don't see any flashing. We press the push button, and it starts flashing. Okay? We press the switch again, okay? And we can see that it was reading that command. Okay? So why isn't it stopping the flashing? Okay? We can assume that things are going on. Okay? So one of the debug tools that we can use is we can actually use the print to serial monitor. Okay? This is super fast. It's actually sending a message back to your computer. It's not something built into this circuit. It's something that will be on the computer display. But we can basically say that if we set it to low, we can say flashing is now off. Okay? Duplicate that, put it into that block, flashing is now on. Okay? So haven't changed any code, we've just put in that one kind of debugging command. Okay? And we go into the serial monitor, okay? And when we press the button, okay, flashing is on. Okay? Something is happening so fast, okay, that it's not actually keeping off as an off command. Okay? So just like I was mentioning earlier, okay, we want to make sure that there's enough time for the code to process, okay, for us as humans to process. We need to remember that a millisecond is insanely fast. If you ever play with a stopwatch, like if you press start and stop as fast as you can, it's hard to get it under 10 milliseconds. Okay? So what we're going to do is we're going to clear out the serial monitor, drop it down for a second, okay? And we're going to go ahead and put in a couple of control wait times. Okay? Give us enough time to go ahead and let things change. Okay? So if it's, let's see if we can actually put it down here. Okay? Let's make this 250 milliseconds. Okay? Let's see if that solves the problem for us. Okay? So the serial monitor stuff is still there. We'll still enable that. So when we turn it on, so it's clear. Start the code. Press the switch. Okay? Flashing is now on. It's a true statement. Okay? Press it again. We wait for the LED to turn off. Okay? That's not quite enough. Okay? Little finicky. Okay? Little hard to go ahead and get that. So let's go ahead and make this 400 milliseconds. Okay? And basically what we're having to do is hit the switch until we see the light. Okay? That turns it on. Press the switch again until we see the light. Let it go. That gives us enough time to go ahead and make this as a working circuit. Okay? So hopefully this video has given you some ideas about things you need to remember about wiring your circuits, testing them as you go. Okay? I didn't leave many comments in just because it was block coding, but it's always a good idea to remember, it's like, what is this block of code supposed to do? Why do we have that debugging tool? Okay? Now, if we were actually going to finalize this product, let's say it was for actual commercial use, we might take out some of the debugging features that we've added. Okay? Where we may have noted, serial monitors for debugging only. Okay? And that goes ahead and is getting it in there. Okay? So again, good idea to have some comments in there in one form or another to help you keep track of your code. Block code, not as critical, but when we look at a more complex circuit and the starts of a calculator, you'll kind of get an understanding of why why those comments help you out. Okay? So again, hope this has helped you out. How to build the circuits, how to start programming them, how to have that process to think through as you're going through it, and recognizing that it's not always going to do what you want it to do. There's always going to be kind of that challenge in making sure that you are explaining the instructions clearly enough that the circuit, in this case the Arduinos, will go ahead and recognize it for you. Okay. So, best of luck in terms of your projects. Pay attention to what's going to be kind of assigned as your challenge. What you're going to do is going to be a little bit more complex than this. Probably going to get into some other loops, but I think you guys can figure this out, and I think this is a great way to give you a foundation to the programming that some of you have had and others have not. But I think all forms of engineering, and in most cases technical careers, are going to require some amount of this as you move forward.